Hello to Darkness344 here. In today's video we'll be covering two ways of transmitting digital data serially using Redstone. Both methods will operate at 1 tick per bit, which is pretty much the maximum throughput you can get on a single wire, and as always a world download will be included in the description, and if you enjoy the video consider leaving a like or subscribing. First of all, what is serial data and why should you use it? In Minecraft we can represent numbers with binary, a high redstone signal being a 1 and a low redstone signal being a 0. We can also create logic gates, perform calculations, and create processors, but one issue always arises. How do we transport data from one device to another? Well, the most obvious solution would be just to run a wire for each bit of data we transmit. This is great if you're only transmitting a few bits of data at a time, but what happens if you'd want to transmit more? Well, we can just add more wires, but this is quite impractical, as you can see, and annoying to build. This is where serial comes in. Instead of running a wire for each bit we transmit, we can instead transmit multiple bits of data down one wire in a series of high and low pulses. Whilst this will reduce total throughput, it means we can reduce the data wires we need down to only one. To see why this matters so much, let's take a look at a couple examples. The first example here is this simple 4x4 pixel display. Using parallel wires, we need 16 individual wires and a signal wire to indicate data has been sent. With serial, we can reduce this down to just 2, a data wire and a signal wire. This allows for greater flexibility on where we put our display, and the shift registers in the design also double up as memory to store each pixel. Further into the video, I'll also show a technique to reduce this down to just one wire instead of having two. Now that you have seen a couple examples and their benefits, let's see how to build them. The first method is quite simple to build and uses two wires. We have our data wire and we also have our clock wire over here. So when we transmit data down this data wire, we also provide a clock signal for the shift registers over here to activate so that it actually is able to capture the data. So that basically just means when the data arrives at any receiver or receiving device, the data line will feed into a set of shift registers, which are these over here, which is using simple repeater locks. And the clock line, which is just this line over here, which is of course run by our transmitter, will basically provide a signal and of course shift the shift registers, meaning that any data that comes in will actually just be shifted in. So we just have this basic example. I'll show you how to build it in a minute, but let's just put some data in. So 1100 1101 for instance, and we just press this button over here. And as you can see, the data comes in and the repeater locks activate again, and of course we get our data. So just by the way, this is of course 1 bit per tick, meaning that every redstone tick, which is 0.1 seconds, we get 1 bit of data transmitted down the line. And if you want to use serial, I'd recommend it transmitting at this speed because, well, you don't really want to be transmitting slower, because if you have the designs, which you do because I'll show how to build them in a minute, then you might as well use them. So first of all, let's work on the transmitter. This can be any sort of 1 tick per bit transmitter. They're vertical designs, horizontal designs, but I'll just show you how to build this horizontal one, as it's fairly simple. So first of all, we're going to want to know how many bits we want. So for this example, I'm going to be using 8 bits because a lot of my computers are 8 bit, and the way we're going to do this is we're just going to place down 8 comparators. So I'm leaving these blocks in between because then we can just place redstone dust like this, and we're going to want to put these comparators onto subtract mode just by pressing it like that. Now we can put our inputs on this side, so you can either run redstone lines into it like this and have levers, or you can have repeaters or whatever, but what I'm going to do is use some redstone lamps like this, and we'll put a lever on here. So if you have welded it, you can of course, you don't have to do this manually. We can just go like this, stack these corners and stack 7 times, and this just makes it a bit easier. So, oh, I think I need one more comparator. So there we go, that's pretty much almost the whole transmitter done, and the only thing we need to do now is run this little line over here, and this stops the comparators from outputting. So if we place these redstone torches down like this, and then place some redstone across that, when we say if we pass a signal through the comparator, normally it won't activate if this line is off, but when we turn this line on, then it will, well, pass through whatever our signal is. So now what we want to do is create the actual data line. So we don't want to output all these signals at the same time. We want to output this one, then this one, then this one, then this one, etc. And of course our time interval being 1 bit per tick. So there are two ways you can do this. So normally what you do is you just put repeaters down like this in between your activation lines. But for this design, I like to actually put the repeaters by the comparators. So like this instead. And how this works is when we activate this line over here, we give it a brief 1 tick pulse, and then all the data gets output to its corresponding bits, and then will flow down serially. Now we need to build the clock line. Since we're transmitting a 1 bit per tick, there'll never be a low signal in between bits. This means instead of sending individual pulses for each bit, we want to send one long pulse which has the length of the number of bits we transmit. Since we have 8 bits, we want to send an 8 tick pulse. So the easiest way to make an 8 tick pulse, if we're only providing 1 tick pulse in the signal line, is to use repeaters. Because if we say put a repeater on 4 ticks and we only give it a 1 tick pulse like that, it will still give us a 4 tick pulse out. So first of all, we're actually going to just make the button to generate our 1 tick pulse. So we're going to use a comparator on subtract mode, and we're going to place a repeater like this with a piece of redstone, and then we can just place some blocks like this. This means we can use a lever or we can use a button. I'll just use a button for now. And when we press this button, we get a 1 tick pulse out here. So now what we want to do is somehow also generate an 8 tick pulse from this output. Well, what we can do is use repeaters like this. So we can use, there are two ways of doing this. Either we use 3 repeaters, this one on 4 ticks, well then all of them on 4 ticks, and then we just connect them up like this. And then when we bring this line down to here, when we activate this over here, we get an 8 tick pulse out. Actually, if I even connect things, if I connect things up properly, of course, we get an 8 tick pulse out like this. Because this repeater activates at the same time this one does, giving us a 4 tick pulse, then this one activates when this one turns off, giving us another 4 tick pulse, meaning 8 ticks in total. The other way to do this, which is just a tiny bit nicer, is we put a repeater here, and a repeater here, and blocks in between, and we can have our redstone dust coming down like this. This one will be on 4 ticks, and this one will be on 4 ticks. And then we have our data, and then we can place our clock line down like this. So this is our clock line, and this is our data line. So just note that this one has to be a repeater as well. So now let's make sure they are synchronized. So for instance, if we just turn this one on down here, and we press this, well, this one activates before this one, but we have to have them synchronized just because it will make things easier. So if we just place another repeater, as you can see, they both activate at the same time, and this is the first bit we send. So that means our transmitter is fully done. Now, of course, you can extend your data line and your clock line as far as you really want. It can go anywhere. Just make sure the lines are synchronized. So if you use a repeater on the data line, you have to also use a repeater on the clock line. And the other thing you have to note is that both these lines, the repeaters always have to be on 1 tick. Say you want to add a bit of delay, instead of adding, say, a 4 tick repeater or something like that, you have to add multiple 1 tick repeaters, because of course we're transmitting at 1 bit per tick, and the data will get corrupted if you do not do this. So let's now build our receiver, and this is actually really simple. So the best part about this design is because we have our clock wire, no additional logic is really required. So what we can do is place a redstone torch down like this, and this line over here will basically activate the repeater locks like this. So then of course we can place down all our repeaters. So if I just place a couple like this, so let's place 8 of course, so 1, 2, 3, 4, 5, 6, 7, 8. And then I'll just place lamps. So now we have 8 lamps and 8 repeaters. Now let's just bring the wires up like this, and just extend it all the way. Then we can place our repeaters over here down like that, and this of course is the repeaters to lock. So now that we've done this, we need to synchronize this line with this line and them actually activating. So if we count the number of ticks our data line will take to reach the first repeater, it's basically 0, but if we count the number of ticks the clock line will take to activate the first repeater, we have 1 tick from the redstone torch and another tick from this repeater over here. So what we have to do is account for that in our data line, so 1 tick for the redstone torch and another tick for the repeater. Of course, no 2 tick repeaters, they both have to be 1 ticks. So let's just try this out. So let's just transmit 10 10 00 11, and I'll just press this over here. And there we go, we got our data out. So one thing to note is if you want to extend this any more than say 8 bits, your redstone signal strength will start running out, as you can see. So what we can do is place a repeater like this for our clock line. These repeaters of course will be set to 1 tick, and then of course we have the rest of our shift register. But then these repeaters down here, because they're no longer in sync with these repeaters, have to be set to 2 ticks like this. So now that these are all set to 2 ticks, these ones also have 2 ticks of delay, so 1 tick, 2 tick. And now of course, because we've added a tick in the system, we have to of course add a tick on the data line, because we've added a tick onto the clock line. So yeah, this is the first design. It's very simple. The transmitter is extremely simple, and the receiver is, well, probably one of the most simple designs for a serial receiver. So this design is very easy to use, though it does use 2 wires. The other method I'm going to show off is this one over here. It reduces the number of wires we use down to just 1, but it also increases the complexity a bit. As you can see, the things are a tiny bit more complex, though it's more on the receiver side than the transmitter. So instead of transmitting a clock signal as well as our data signal, we can actually transmit an extra bit at the front of our data, which is basically signals that data is being sent. This basically means that when the data goes into the receiver will get that initial first bit, and it will basically start the shift registers and allow the rest of the data to come in. And then after a certain period of time, for instance, because we only have 8 bits, the time will be 8 ticks. The receiver will shut off and of course lock the repeaters, stopping the shift register. So let's just put in some data. So let's just transmit 10101010, and if we press this button over here, we get our initial signal bit going in and our data being saved. So yeah, it's a pretty simple concept, but the receiver is a bit more tricky, and timing wise is quite, yeah, it can be a bit complex. So of course, let's start off with our transmitter. We're going to be using the same design as our previous one, so I'll just go back to our previous design and I'm just going to break these wires because we kind of no longer need them. We'll just do the other design over here instead. So this is where we kind of left off with the first method. So the first thing we're going to do is remove the clock wire, because we no longer need this bit. Because we're always going to be sending that 1 bit down, we don't need the clock wire of course, so we'll just get rid of it completely. Now what we want to do is to actually get that initial bit. So what we're going to do is, let's just bring a repeater here for instance, and a signal down like this. So let's make sure these are just synchronized. So if we leave this one on and we press this button, this should be on for 2 ticks. Yeah, so we got 2 ticks. So now if I turn this one off and this one on instead, we should get our initial signal pulse, then we should get a break because of the 0, and then we should get another pulse, and then of course all zeros. So let's just see that. So 1 0 1, there we go. So that means this transmitter design works. So as you can see, the transmitter is a bit more simple than the design with the clock wire. Then of course we can just remove these repeaters as well, because they're no longer really needed. And that's pretty much the entire transmitter done. So this can also be extended, which I'll show you in a minute. So if you want to have more than 8 bits, we can extend this, but I'll show that once we complete the receiver. So this line over here, we can of course extend as always. So let's just extend it a bunch. We'll just put the receiver over here somewhere. So I'll stick another repeater in here. And of course, the repeaters always have to be on 1 tick of delay. So to build the receiver, this design was kind of by Maizuma Games. I'll leave a link to his video down in the description. But I've kind of modified it a bit to make it kind of a bit more simple. So the way the concept kind of works is we have a comparator set on subtract mode, and it basically passes a signal back into itself like this. So what happens is, say if we just pass the signal in through this, it's almost like a SR latch. So as you can see, we set it by passing a signal like this, and then we can also reset it by passing a full signal strength into the side like this. So what happens is it's normally set like this, and this will go to our shift registers, this line over here, and basically that initial bit that we send in the signal bit will activate this comparator like this, so on a 2-tick pulse, and then of course all the repeater locks will be unlocked until a specified amount of time, so being 8 bits, it'll be 8 ticks, has occurred, and then it will be set again like that. So the first thing we're going to want to do is build that comparator circuit. So we're going to block out like this, and this redstone dust will go into a repeater set to 2 ticks, and then we can place a comparator down like this, set on subtract mode, block up like this, and place a piece of redstone dust down here. Then we can place a repeater which goes into a block, and then another piece of redstone dust over here. That means we can activate this circuit like that, and we can also reset it like this. So now we've built the set part of the circuit, we need to also build the reset part. So if we go a few blocks back, we're going to place a repeater set to 3 ticks, and then a piece of redstone dust. And then this means that if we pass in a 1-tick pulse, as you can see, it briefly gets unset, then reset. So of course, there's no ticks of delay because we haven't actually added any of our bits yet. But for every bit we add, we're going to add 1 tick of delay. So say, of course, we have 8 bits, we want 8 ticks of delay, so we're going to have 1 4-tick repeater plus another 4-tick repeater. And this delay will come after this initial 3-tick repeater. And so when we hook this up, let's just give that a quick pulse again, the circuit turns off for 8 ticks, then turns back on. Now let's actually create the part where we have the repeater locks. So because we have the signal over here, this can go straight into repeater locks like this. And what we want to do is somehow get our data line from here to over here. So the way we're going to do this is place down 3 blocks like this with repeaters all set to 1 tick. So that's 3 1-tick repeaters which go into a block, and then we can place a piece of redstone dust like this. So that means when we pass data in like this, as you can see, the data is able to get into this repeater over here. So now over here we can of course extend this as much as you want. You can of course place the repeaters right next to each other like this, but then you won't be able to get signal out. So what I like to do is leave a block in between and place a redstone lamp like this. So we're going to need 8 redstone lamps, and that also means we need 8 repeaters as well, so I've just placed those in. And of course all the repeaters have to be set to 1 tick. So then what we can do is place these repeaters down so we get the repeater lock, and we're just going to, for every repeater we have, we're just going to place another repeater facing into it. And now we're going to actually run this line down so it connects to each of the repeaters like this. And as you can see, the signal just reaches the 8th lamp. So yeah, that's pretty much the design. Don't worry if these lamps are not on or off, that was because I was testing. If you want to make this circuit work, so we're just going to break this, let it all run through, then place it back down again, and I see this is meant to be on 1 tick. To activate this circuit for the first time, we're just going to power it like this, and wait till all these repeaters get locked. And then once this is done, we can actually try sending data. So for the first test, we'll just put in the number 11001101, and if we just press the button, of course we get our data flowing through, and there we go, we get our number. So it only uses 1 wire, unlike the 2-wire design, so it's a bit more versatile. Let's just try a different number, so 10101101, and if we press the pulse like that, we got our data over here. So now how do we actually extend this? We are only using 8 bits over here, but say what happens if you wanted to have, say, 16 bits or even 32? Well, the problem we have over here is that this redstone line is running out of signal strength. And if we place a repeater like this to repeat the signal strength, we have a bit of a problem because this repeater over here is not synchronized anymore with these repeaters over here. So this repeater has to be synchronized with these. They both have to activate at the same time, or we get issues with the data. So if we just place all these down, let's just do 8 of them, for instance. Say we want to transmit 16 bits, we're going to have 1, 2, 3, 4, 5, 6, 7, and 8. And now I'm just going to place these ones in, locking them, and these are all going to be set on 1 tick. Now, because these ones over here, from the source over here, they only take 1 tick to activate these repeater locks, because we have 1 redstone dust, then a repeater, then it goes into the repeater lock. But the ones over here take 2 ticks because we have this repeater, then that repeater. So what we're going to do is to synchronize it, all these repeaters behind this one over here are going to be set to 2 ticks, like that. And say you had another repeater in the chain, so one over here, these ones would then be set to 2 ticks, and these ones would be set to 3 ticks. So this is great and all, but it also means we need to extend this line over here. Because we've added 8 more bits, we are of course going to need to add 8 more ticks onto this line over here. So 2 more 4-tick repeaters like that. And then the last thing we have to do is of course account for the additional 1 tick of delay between these lines. Because while these are synchronized, they are 1 tick slower than they used to be. So we're going to add that 1 tick over here, just by placing another 1 tick repeater. So for every additional time you extend it, of course, since you resynchronize it, you also need to place a repeater down on this one over here. So this receiver is fairly simple to understand. This repeater is always set to 2 ticks and does not change. This row over here, this repeater is always set to 3 ticks, does not change, and for every additional bit you add a tick of delay in repeaters behind it. Then the last row over here is fairly simple as well. It normally only has 3 repeaters, but for every additional time you extend it, you add another 1 tick repeater. So that's pretty much this receiver. Now let's actually fix the transmitter so we can transmit all 16 bits of data. So the way we're going to do this is first we have to figure out how far our signal strength reaches. So when I press this button, it pretty much just goes to this torch over here. So if we place a repeater down like this, when we press this button, that repeater should light up. And then to extend the signal just a bit more, I'm going to place a block like that, so we can get it out here. Now we're going to build 8 more lamps, so I'm just going to block along like this, and that also means 8 more repeaters and comparators. So first of all we have 1, 2, 3, 4, 5, 6, 7, 8, and then we'll place our redstone dust in. So in comes the comparators, of course all being on subtract mode, and then the redstone dust in between the comparators. And of course last thing we could do is extend this signal down like this, then place our redstone torches to stop the inputs from outputting. However, you may realize that this line is no longer synchronized because we've added that 1 tick of delay between these torches and these torches. So what we can do is the repeater over here, we can break and just replace with a normal piece of redstone. And of course we can break this block over here too, because we have these comparators are being powered anyway by either side, so we don't need to do some like fancy wiring. So there we go. Now we can send 16 bits, so let's just send the number 10101101 00111101, for instance. Now if we press this button, we should get a full 16 bits of data, and now we have our number we sent. So 10101101 00111101. And there we go, that's pretty much this transmitter. So I hope this video helped with understanding serial data and how it can be used in Minecraft. I hope you enjoyed the video, please like and subscribe, and I'm out.